Hey, what's going on, guys? Kamakin's here. Last video we've drafted the core data structures needed to drive the entire game basically, and now it's time to render the graphics to the browser, because so far the output we had was this console output. So we have our Tetris board data structure being printed. And now, before we start writing the function to actually render the entire Tetris board with the tetrominos that has already been settled down there, and just to remind you one more time that those tetrominos that are falling down currently are not yet being settled down, that you can move back and forth like left, right, you can force them down, they do have a collision detection. That's going to be a separate logic, a logic separate from the one that is responsible for the static elements of the game. So by saying the static elements, I mean the Tetris board itself and those tetrominos that has been settled down already. So for instance, if I use this as symbols to say draft a couple of tetrominos here, like so, for instance, and let's just go and update. Now you see like we have these two tetrominos being dropped down, right? Yeah, by the way, I just want to make sure. Yeah, it's exactly the board edge. So our goal for this video is to write a function that would be generating the view element that would draw exactly the same thing. So like I mentioned in the intro video, for this series, the way I'm going to be handling the graphics is probably the most simplest possible ever way. I'm going to be using HTML table, so it's a prehistoric way of doing things really, but it's really straightforward, and it's very easy, it's very didactic, that's why I love it. And also the principle of rendering a single frame and then followed by rendering frames depending on how fast you want the game to run is going to be really similar to the approaches if you want, say, use this with HTML canvas element or whatever other way. If you're not doing this in JavaScript, if you're doing this in Python and Pygame, for instance, that would work exactly the same. So the principle is the same. I just want to emphasize that the principle of rendering is the same. So once we have the internal data structure, we can then very simply render this to whatever output we have using those functionalities that are available. So currently we have three types of elements. So we have empty space, empty cells, we have the Tetris board edges, and we have the tetrominos themselves. And I want to color each of this element with its own color. Well, somewhat more advanced, well, it's not really advanced, but I don't know, sophisticated, complicated way is to give every single tetromino a single color, but that slightly complicates the code, and I want to keep things as simple as possible. And once you master this basic version, it's not going to be a problem to add colors later on. So in this implementation, we're going to be sticking to three colors. So background is going to be white, the Tetris board is going to be gray, and the tetrominos is going to be somewhat red, a brick-like color. So we'll start this video by copying the part 1 HTML source to the empty file part 2 HTML. So here I just did it, and we'll start by defining a few more constants for colors. So let's put the colors here. So I want to have the constant of the background color, I hope I spell it properly, color, and it's gonna be equal to white. We can give the color names here, so fortunately it's loaded in JavaScript. Then the wall color is gonna be equal to gray, and finally const tetromino color is gonna be equal to color called firebrick. That's the exact color from the demonstration of the eventual game from the very first part of this tutorial series. Alright, so now let's define another function. So we don't need this print board for now. We're gonna be using this later on, maybe, potentially, but not now. So now I want to draw a Tetris board and settled pieces to screen, to browser basically. So let's create a function called draw Tetris, and then we'll have the function draw tetrominos, or draw tetromino, because these are separated again. So this is important. All right, and the overall structure is going to be very similar to what we have here in our print board, but before let's initialize the colors object, and we're going to be doing the following thing. So here we have the empty space, hash symbol, and @ symbol. So let's define them. So we have the empty space. It's going to correspond to the background color. So let's provide this one. Then the hash symbol is going to be equal to the wall color. And and finally we have the @ symbol, which is going to correspond to the tetromino color, right? Okay, so far so good. So here want to define colors object list. Let's call object. Okay, and now let's define the Tetris HTML Tetris graphics. Let's say graphics. So I want to define the variables. So variable Tetris HTML, and literally it's gonna be a table, as mentioned already. And the logic, yeah, again, it's very similar. So I can just grab this part, copy from the print board, just to avoid you wasting your time watching me typing this from scratch again. So it's all very, very similar. So here we don't need this. So here want to populate Tetris HTML string in this case. So by default, and here, yeah, we don't need this as well. So rows, columns, the element itself is Tetris, all right. We probably go for console.log in this Tetris HTML before actually appending this to the DOM element, like as the DOM element. So Tetris HTML. So first I want to observe this as the string, just for didactic purposes, nothing much. So draw Tetris, and now it should print just an empty one. All right, so empty one, which is the case. Okay, now the next thing to consider, let's define the HTML table. I'm going for a very archaic definition, so please forgive me that, but it's fairly enough for our purposes. So I want to say table, align center. I'm sorry for not using CSS here. Just no reason for that. I just want a centralized table, and it's really faster to do it this way. So align center. I actually still do define some styles here. So for instance, I want the border 1 pixel solid black here, and also I want the cell spacing equal to 1 pixel. So yeah, this should be just fine. Here we want to close HTML table tag. So probably we would be working without this, but just for clarity, so Tetris HTML plus equals, and here table, and also we want to have the table body here starts like this, table body, and here we want want to close the table body, right? Yeah, let's have a look if it prints the string. So table align center border 1 pixel solid black, cell spacing, table body, and table tag is closed. All right, so far so good. We can even well, we could add some new line characters, but I think that's a bit of an overkill, so let's drop that. Now every time we go in for a row, so here we want to append table row tag, so we can say Tetris HTML plus equals, and here open the tr tag, and here actually here we want to close tr tag and do it like this. All right, so let's have a look. All right, so now we have 1 2 3 4 5 6 7 8. Well, it's maybe here we can actually add a new line. It's probably, yeah, it's just a bit more better visually. So starting from, or even better, like, okay, still quite okay. So 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10 11. So 21 total, which is exactly the number of rows we have here in our board structure. So we have 21 table rows, which is what we want to have here. And the most essential one is to create the actual table cells. So here we want to append table data tag. So these are the game board grid basically. So here we say Tetris HTML plus equals, and so I'll define this, I'll draft the structure, and then would be adding some indentation. So we want the width equals to some value. Sorry guys, I just don't remember the width, so let me reference my previous code and see what exactly the width is. Oh, actually cell size, so it's 30. Okay, so for now we can make it just 30 pixels, and then height equals to 30 pixels as well. Yeah, I know I could have done this using the style tag, but I don't want to. Also, we want to define the ID, which is going to be equal to whatever this square is, right? This is important because that's how we would be referencing the GUI elements. So here, the square. Okay, and yeah, let's actually print this out to see how it works. So we have tr table data height with ID is equal to 0, and closing the tag ID 1 2 3 4 5 6. Yeah, so it goes all the way along there. Okay, so now another important, well, actually, let's define the tables, the cell size. So let's better call this one GUI. So starting from cell size, it's gonna be equal to 30 pixels. So here I just say cell size, and I'm just going for next, like this, next row plus cell size. because if you want to change this, you can change the single cell size variable and not touching the entire code. That's very handy. Yeah. So ID, then what? Also, I want the background color, and another retro attribute is BG color for this purpose. And here plus, and let's make it the new line as well. Here I'm referencing this colors object, so colors, and the key is taken from the Tetris indexed by the square. So Tetris indexed by the square would give us either the white space or the hash symbol or the or this one @ symbol, and depending on that we'll have a corresponding color for our cell element. So let's have a look. So now we have BG color, yes. So here we have the gray, here we have white, so they all are different. So far so good. And I believe that probably, so let's see if, it just doesn't even show. So just to make sure that it kind of closes, the last tr closes the table body. Yeah, I think that we actually ready to render. We are ready to render. So here we want to render Tetris to browser window. Right. So here I say document.get element by ID, and the element I'm looking for is this div. So it's called Tetris. That's cool. So here I want to say dot inner HTML, and this inner HTML is going to be equal to Tetris HTML. And quite a cool and fun thing here is that it's going this inner HTML of the single element is going to be updated quite fast, depending on how fast we want our game to be, and that would make it a sort of a video game already. Well, actually Tetris is the video game, so we need to render the frames. I just want to mention that it's the matter of rendering the frames. So this was the HTML canvas element. It's done there like by making it all black or all white every iteration. Here we can just update this inner HTML string, and that's enough for updating our keeping like maintaining our refresh rate, so like refreshing the frames all of the time. For now we're going to be going only for a single one. And yeah, so now we already have our Tetris being actually rendered, which is quite fascinating, right? So the next step to consider would be to fit the tetromino that is falling dynamically, that can be moved back and forth within this Tetris board in a separate function. So that's going to be the topic of the next video. This is it from my side, guys. Thanks for watching. Until the next time, and take care.